Water, a resource whose existence life cannot do without. Water is the lifeblood of hydro systems or hydroelectricity production. It is the power of this resource that is used to propel generators that eventually produce electricity. In industrial power production, the hydrological cycle is an established system that picks up as a journey of water from catchment areas to its final thrust that ensure electricity production. Lunsemfa Power Hydro Company Limited, specializing in hydroelectric power generation, operates Mulungushi and Lunsemfa power stations. LHPC is a privately held independent power producer in Zambia, based in Kabwe, Central Province. The life of LHPC's power stations begins in the Mulungushi and Lunsemfa catchment areas into the reservoir where the journey of water is initiated.
We're looking at the journey of the water, and it is from the headwaters into the reservoir, then down into the diversion dam, which is where we are now, and all the way to the diversion canal. Engineers do so much in order for this whole process to work. The water will now run through the diversion dam into the diversion canal, down into the penstock, which will actually push the turbines in order for them to turn and bring about the electricity that you are enjoying right now. It's the journey of water all the way from the dam to generation of electricity.
The scheme is composed of the main reservoir and then the river channels, the water channels all the way up to the power plant. The reservoir is where we actually impound water during the course of the rain season, so that then we can have a planned, scheduled production covering the entire period of the year.
For the Lunsemfa watercourse, the intake tower also shows the previous dam water levels and performance during earlier years when rainfall was good. The water from the reservoir goes through this intake tower to commence its journey. On the other side, a walk on the hillside of this reservoir takes you to the depth of the intake for the Mulungushi watercourse. On the release side is the newly installed discharge valve, which has an automated regulation of water.
Behind me is Meter Hills Reservoir, whose storage capacity at full supply level is 680 million cubic meters. And of course it sits on the Lunsemfa River. The source of the Lunsemfa River is in the northern eastern side of Mukushi town, and that's where basically the headwaters are of Lunsemfa River. So the Lunsemfa River traverses or flows through Mukushi farm block up to this point. And intermediate are of course tributaries that contribute to inflows in the Lunsemfa River, which of course the major ones being the Munshibemba River, on the eastern side of the catchment, and of course the Mubalashi River, which is on the western side of the catchment. So as water flows from the headwaters, of course it collects part of a runoff from these two tributaries I've mentioned, and of course the other ones which are a kind of minor, but also the other sediments or materials that are carried along as the water flows into the reservoir that is before me. From here, water flows covering a distance of about 36 kilometers downstream the existing dam into the Lunsemfa Power Station diversion reservoir, where the water is diverted for hydropower generation. From the Meter Hills Reservoir, we have the intake gates where water is basically regulated. And we basically regulate how much water goes downstream for hydropower generation. And there are two basic gates that are operated on a daily basis, depending on how much water is required for hydropower generation.
Depending on how much water we've been able to capture or been able to harvest, water is discharged into the river through what is normally called the dam discharge valve. This is the valve that is usually used to regulate how much water you would want to discharge for the purpose of achieving the kind of generation that you desire to generate. So for instance, if we want to generate say 10 megawatts, or we want to generate enough capacity that will supply maybe a town like Kabwe, we would then look at what kind of parameters would be able to give us that kind of level of discharge. And then from there we'll do the computations, and then the engineers will be able to set what volumes to discharge and so forth.
The journey of the water begins to gain aggression as it arrives at the diversion dam and pushed through controlled gate valves into a watercourse of concentration.
Once the water is discharged from the dam, the water is allowed to flow back in the river, a stretch of about 2 kilometers or so, up to this point, which is called the diversion dam. Ideally, this water is supposed to continue to flow through the river, downs across the spillways, but because we want to utilize this water for the purpose of generation, the water is then diverted into the canal. It is allowed to flow for another 2.5 kilometers to what is known as the forebay.
The water then arrives at a point called the forebay, where it is held temporarily in readiness for release into pipes called penstocks.
Once we discharge the water from the diversion dam, so we've got the canal 2.6 kilometers, which bring the water now to here. This is our forebay. So this is just a temporary holding point for the water. Then from here, the water goes through some trash racks, which trap any debris. Then the water goes into the penstocks, which are able to see down that side. So down in the power station, we've got 4 units. Unit 1 has got its own dedicated penstock. Then unit 2, 3, and 4, they share water from penstock number 2 and number 3. Penstock number 2 and number 3 join into what we call a manfold. Then from the manfold, each water turbine has got its own dedicated water supply line.
Where we are standing here is on the top of the gorge, and we have a stretch of about 1 kilometer of the penstock pipes. The penstock pipes are the pipes that then carries this water to go down and get connected to the turbine, at which point then water is now allowed to go into the turbine, which spins and be able to convert the potential energy from the water into the kinetic energy used then to convert that to mechanical energy and be able to generate electricity. So the journey of the water actually is nearing to the end as it travels from this point for the next 1 kilometer where the powerhouse is situated.
It is here that the adventure begins.
So the whole story told, and everything begins to become very interesting now that we have to go down the gorge, talking about the heights and also, you know, the amount of water that has to run down those penstocks with the force that's going to push the turbines to turn so that electricity can be produced.
Getting on a transport called the skip to ride alongside the water transport pipes or penstocks down into the gorge to see and experience the real deal.
So the entire team has joined on the skip and we're all going down the gorge. And that, for safety, is to make sure that I don't fall out. Okay, so we're ready to go. I'm not so sure I'm liking this anymore. This tilt is too steep, right? We're going right down the gorge, and it's about 1 kilometer from the start of this journey right to the bottom of the gorge. And this guy is moving at 4 kilometers per hour, which is just like some 4 seconds per, I don't know the calculation, but right now I'm looking down onto the gorge, and I can't wait to see what is down there. Okay, so we are about to conclude our 15-minute journey of the 1 kilometer tilt down, and I can assure you it's not as exciting because 15 minutes here to me looked like 15 hours. But anyway, we are just about to get there, and I'll show you something there. The years 1925 to 2005. Look at that, 2009.
Finally, arrival into the place of production. Over 100 years of authentic solid-state machines with a sound that feels like electricity. And surprisingly, a workforce that is going on about their work like normal life.
Right now we are in the control room for the Mulungushi Power Station, where we are now controlling 4 generator units. The units consist of 2 machines. One side we've got a Pelton turbine, directly coupled to the other side where we've got a synchronous generator. And together these produce the electricity which is transmitted into the grid. Each unit has a double jet Pelton turbine which converts the potential energy in the water which is delivered down into kinetic energy. Then the kinetic energy is used to convert the mechanical energy into electrical energy in the synchronous generator. And right here behind me you are able to see the control panels where the operators are able to start the generator, pick up the generation and be able to record how much power is being exported into the grid. Once the power has been generated, each of the 4 generating units has got its own step-up transformer. So Unit 1 and Unit 4 generate at 11 kV and step up to 66 kV, while Unit 2 and 3 generate at 2.2 kV and the voltage is stepped up to 66 kV. These connect to the common bus bar where we've got 2 transmission lines which connect Mulungushi Power Station to the national grid.
What is good here is that the water that has run through the machines to produce the so much needed electricity is released back into the river as it continues its journey for other users and stakeholders downstream without loss of any water.
Unfortunately, because of the changing weather patterns, people tend to shift from one agriculture area to another, and we need to have a balance between the need for electrical energy and the need for agriculture. And right now as LHPC, we really want to appeal particularly to government to be able to assist particularly the peasant farmers to improve in their agricultural activity.
The journey resumes in reverse this time.
Okay, now that's like all of us calling it a day, going back up the reverse way. It's interesting. We've really seen what goes on down there, and I'm sure there's a lot to appreciate apart from the landscapes, fresh air and the breeze that is here, the slope down there, so much to see.
Previously, more than some 20 years ago, the dry spell used to come every 10 years. But of late, it's like every after 2-3 years, we tend to have a drought.
All that begins well, ends well.
Wow, that's it. 1 kilometer up, 4 kilometers per hour, and 15 minutes in total, moving backwards in reverse. And that's the appreciation of the journey of water all the way up to down where it pushes the turbines in order for it to produce electricity. On behalf of my colleague Patrick Chilongo, I'm Alec Mugala, and we say thank you for joining us. Join us next time again. But for now, we say God bless you and goodbye.